Okay, good morning, students. Today's session we are going to discuss about the finite automata. So, what do you mean by finite automata? The finite automata it consists of the set of states and the finite transition from one state to another state that take an input from someone alphabet. Someone alphabet. So there are two different types of finite automata. One is a deterministic finite automata. Another one is a non-deterministic finite automata. So what do you mean by deterministic finite automata? Na? There is one and only the state to which the automata make a transition from its current state. So this is a DFA. Another one is a NFA. So there is more than one state to which the automata can make a transition from its current state. So this is called as an DFA and NFA. So DFA means there is one and only the state to which the automata make a transition from its current state. So NFA means there is more than one state to which the automata can make a transition from its current state. So the DFA means what is this? No, it consists of the five tuples a is equal to q summation del q naught comma f, where q capital Q is a finite set of states, summation is a finite alphabet, and del is the transition function or the mapping function. Here q naught is the initial state and f is the final state. Another one more thing is what is the formal definition is q represents the finite set of states and summation is a finite set of input alphabets, and q naught is the initial state or the start state and f is the final state. Okay, so another one more thing is del is the mapping function. So in the del is the mapping function that takes the two arguments as an input. So one is the state, another one is the input symbol as an arguments, and return the states. So return the state is a new state. New state. So for example, we are telling is del of q comma a is goes to p. So q is the current state, a is the input symbol, and p is the new state that should be represented. So simpler notation of DFA is the two notations are used to represent the DFA. One is the transition diagram, another one thing is and the transition table. So what is mean by transition diagram is the finite automata can be represented by the graph. So the nodes are considered as in states. The arc are considered from Q to P if labeled by the set of input symbol. So del of Q comma A is equal to P. So what is the meaning of this? There is everything is represented in the graph. So the nodes are considered as a state, and the input flow arc may be the input flow from one state to another state. That is called as an. Another one is if no arc means no such input A. Suppose we just start the start state can be indicated by the word start and by an arrow, and the accepting state that can be represented by an double circle. You just know this is a simple example. So here q0, q1 and q2 are the states. So the start symbol is represented as an arrow mark, and double circle that should be represented as a double circle, and there is an input flow between the two different states, 0 or 1 or something else, you just know it on. And the transition table. So what in by the transition table is the conventional tabular representation of the functions like del that takes the two arguments and returns the another state. So in the row of the table corresponding to the states and the column of the table corresponding to the inputs. You just note it down. And so here you just represent uh, the transition table. So 0 and 1. So here the set of states q0, q1 and q2, and some of the input symbol is 0 and 1. So suppose if you are reading some inputs na q0 comma 0 it goes to q2, or q0 comma 1 it goes to q1. So it goes to some other state. Another one more thing is extending the transition function. So what do you mean by the extension transition function? So here the mapping function has to be represented. So here this can be represented by the two different steps. One is a basis step. What is a basis step is del of q comma empty. Empty means we are not reading any of the input symbol. So automatically we are still in the same state only. So induction step means del of q comma wa is equal to del gap of q comma w comma a. So first we just here the size of the input string may be 2. That is we just divided into 2. First we just find the value of del of q comma w and comma a. W is a string and a is an input symbol. You just note down this kind of information. Another one more thing is the language of DFA, the acceptance of the strings, and the DFA A is equal to Q summation del Q naught and F accept the input string W if and only if del gap of Q naught comma W is in F. Just note it on languages of the finite automata. The finite automata A accepts the languages of L of A is equal to W such that del gap of Q naught comma W is in F. So you just note it down, and then suppose we just generate the some input symbol given a DFA accepting the following languages over the alphabet 0 comma 1 means set of all the strings ending with 0 0. So ending 0 0, that is the here we are using the two inputs, so it needs the three different states, q0, q1 and q2. So q0 is initial state and q2 is the final state. So ending with 0 0 only. Suppose we are ending with 0 0, so we just if we are having 0, definitely it moves to the next state only. So suppose if the zeros if the input may be 1 means we are not reach on the and the next state we can move on to the previous state also. So this is the one diagram. Another one more problem is given a DFA accepting the following languages over the alphabet 0 comma 1, set of all the strings with the consecutive three zeros, not necessary at the end. So three zeros is there, three consecutive zeros, not necessary at the end. So automatically it needs four, and you just note down. This is a diagrammatic representation of this DFA. Another one more thing is 0 1 1 as a substring. So 0 1 1 as a substring means zero three inputs, four states. You just take the 0 1 1 as a substring, so you can note down the diagrams also. Another one more thing is given a DFA accepting the following language over the alphabet 0 comma 1, the set of all the strings begin with 101. So how will you take that? That is 101. Suppose it reaches on the destination or the accepting state. Suppose if it is not reached on this, so you can move it on the some dead states also. Another one more thing is given a problem or given a DFA that accepts the following languages over the alphabet 0 comma 1, the set of all the strings with the three consecutive zeros. So consider the following transition diagram to check the given input string 110 111 is accepted or not. So we just check, define, and this is a given problem. So we just start saying here. From this we have the four different states. A is the initial state and D is the accepting state. Here the input flows are moving between the two different states. The table is there. So A, B, C, D. Here 0, 1. So A comma 0 it goes to A comma 1 means it goes to B, and B comma 0 means C and B, and AD and C also. So you can take it del of Q comma A is equal to A. So A comma 1 means goes to B. Again A comma 1 1 it again goes to B. A comma 1 1 0 it goes to C. Del of A comma 1 1 0 1 goes to D, and del of 1 1 0 1 0 means goes to B, and del of A comma 1 1 0 1 0 1 is goes to B. So finally it reaches does not reach the accepting state, so it's not accepted by the input string. But we can take some other input string 0 1 1 0 1 1 1 0 1. So we initially it should be A. Okay, 0 1 means it goes to B, 0 1 means goes to B, 0 1 is goes to B, and 0 1 0 is goes to C, 0 1 0 1 is goes to D. So it reaches the final state. So the given string is accepted by the DFA also. Okay, suppose next one is the given DFA accepting the following language over the alphabet 0 comma 1, all the strings with the substring